Okay, so we are going over Module 4, Lesson 23, and we're going to be doing exercises 1 through 10 on this video. As it's stated in the Schoology assignment, I will be doing exercise problems 1, 2, 3, 4, and 5 with you, and then you guys will try 6, 7, 8, 9, and 10 on your own without watching the video. So you'll pause after 5, try the last 5 on your own, and then press play to watch me finish off the exercises and check your work. Please make sure that you spend the second half of these exercises working independently. That is very important. You need to practice doing this and not just copying it. So let's get started here. First thing we're going to do is we want to read exactly what it's asking of us. And you can see that the directions are right here. So we'll go ahead and read them. So exercises, and it says substitute the indicated value into the variable and state in a complete sentence whether the resulting number sentence is true or false. If true, find a value that would result in a false number sentence. If false, find a value that would result in a true number sentence. So there's a lot of things that we are doing here. The first thing, though, we got to know is we have to understand what the indicated value is. So what do they mean when they say indicated value? And then we got to understand what variables are, and we should know what that is, but if we don't, we need to understand that. And state in a complete sentence whether the resulting number sentence is true or false. So we really have to understand what true or false is. If true, find a value that would result in a false number sentence, okay? So if it is true, we have to go and find a value that would make it false. If it's false, we have to find a value that would result in a true number sentence. So we're going back and forth here, but we got to understand some of these key terms. So first off, our variables are here. So that's a variable, right? And our indicated values are going to be right here. So substitute 8 for x. That is our indicated values. Okay? So when you see it over here, this is our indicated values, and so on and so forth. It will display like this throughout the entire exercise page. So we have the variable figured out. It's our unknowns, right? Our letters usually. We have the indicated value figured out. It's what it's asking us to substitute in for. And then we have to realize what is true or false. So really quickly, this is nothing new. We do a lot of true or false work in here. But if you say, the sky looks blue, is that's a statement, but is it a true or false statement? Is it correct, right, or is it wrong? Correct or incorrect? That is what we want to know. Okay? We want to know, is what it's saying here going to be correct? So if you didn't go through the terms before watching the video, then you didn't define what each of these symbols mean. Okay? And you want to make sure that you have all these symbols defined. So I'm not going to do that here. If you haven't defined these symbols, what you need to do is you need to go back, and I believe it is number 1 of this assignment is to actually in your math journal, copy down all the symbols and their definitions and memorize them. And you should have taken a assessment on these terms before coming over to this assignment anyway, so you should have these mastered. That is why I'm not going over them here. Let's go back to where we were at. So right there we have an equal sign in number 1. So the equal sign for number 1 is saying that 4 plus x is equal to 12. Now it's telling us that we need to substitute 8 for x. So if we do that, we go ahead and we say, okay, 4 remains the same, the addition remains the same, but the x is substituted for 8. So now we're going to say 4 plus 8 is equal to 12, and that is a true statement. We know that if we add 4 plus 8, we are going to get 12 because 8 plus 2 is 10, and then 10 plus 2 is 12. So true, the statement is true, and they want you to actually go beyond just what I did right here. They want you to do more than just say true. They actually want you to write a full and complete sentence. So they want you to do it just like this. They want you to say, when 8 is substituted for x, the number sentence is true. However, they also, so it says incomplete sentences, so that's something that's very important to do. But when it's true, so if it's true, we have to find a value that would result in a false number sentence. So this is an example of it being true and us needing to find a value to substitute that is going to make the statement untrue. So pretty much anything that we substitute that isn't 8 is going to result in a statement that is false. It's going to result in a statement that is not true because 4 plus 8 is 12. And if we go through, unless we get into negative integers, there's not a lot of combinations that we can do besides what they've given us to equal 12. So we can say really easily, when 2 is substituted for x, the statement or the number sentence is, well, we don't want to say not true. We want to use the term false. Okay, so very easily, we're just looking, again, just to recap, we're just looking here. Hey, what are they asking us to substitute x or any variable for? In this case, it's g. What are they asking us to substitute the variable for? What's the indicated value? Where is the variable? So I can just plug it in, plug and play. And then when I plug and play, is the symbol here, is this equality symbol true? In this case, it's an inequality symbol. Is it true? So we'll look at the, here's an equality symbol, and then we'll look at the inequality symbol down below, and we'll go over this one together. So substitute 4.5 for g. So we know that 3 3g is the same as saying 3 times g. And so we want to know is greater than 15 if, and that's a big if, we substitute 4.5 for g. So if we plug and play, g becomes 4 1/2. We still have that inequality symbol. And now we got to solve for, let's bring it over here so we have more room, 3 times 4 1/2. That's our whole number. So easy way to go ahead and make this a mixed number so that we can actually do the multiplication a lot quicker. We're just going to say, okay, 4 times 2 is 8, plus 1 is 5, plus 1 is 9. So we are going to do 9. This becomes 9 over 2. We drop down the multiplication sign and the whole number, but the whole number becomes over 1. So we're going to go ahead and 3 times 9 is going to give us 27. Okay, so that's going to be 27 on the top or on our numerator. And then 2 is the bottom, okay, our denominator. And what that tells us is that we got to take 27 and divide it by 2, okay? And then we'll find out whether 15 is greater or not. So 27 divided by 2, well, we know that 26 divided by 2 is going to be 23, because if you had 26 and you split it up into 2 different sections, you would have 13 on one side and 13 on the other side, and that would equal 26, okay? So you know that 27's got to be 1 more. So if we change this 6 to 27, well, we're still missing 1. So how could we get 1 more piece of this pie? Well, we could just split 1 up into 0.5, cool, or also known as 1/2. Okay, so we can do that. That means that each of these pieces gets 0.5. So the answer would be 13.5 is greater than 15. The Pac-Man is eating the one that's supposed to be bigger, but as you see, is 13.5 bigger than 15? I think not. So when 4 1/2 is substituted for g, or for g, sorry, this lowercase g, the number sentence is false. Okay? Why? Because when we did the math, 13.5 is less than 15. Well, what could we plug into there to make the statement a true statement? Because again, we don't just go and say whether it's true or false. We have to, if it's false or if it's true, if it's false, we have to find a value that would result in a true number sentence. So let's look at so it's not true now, but if it was 4 1/2, what could we do to make it true, what would we need? We would need the answer to be over 30 here, because 30 divided by 2 is going to be 15. This is not a equal sign. This is a greater than sign. So this has to be equal to 30.1, okay? At least to be more. So we could look over here now and see what number is going to give us 30. What number times 3 is going to be equal to 30? Well, we know that if we multiply 3 times 10, that's going to be equal to 30, but we need to go over 30. So if we multiplied 11 times 3, we would get 33. So what would we need for this to be 11? Well, if this is a 4 on the side, okay, we're going to need to make sure that that number changes. So let's try a 5 instead. So let's say that this is 5 1/2 instead. Now that it's 5 1/2, we say 5 times 2 is 10, plus 1 is 11, which means our mixed number equals 11 over 2. So if we say 5 1/2, now we have 11 over 2 instead of 9 over 2. So 3 times 11 is going to be equal to 33. The denominator is going to stay the same at 2. And then 33, okay, is going to get split up in half by 2. Using a number bond again, we can break down 33 to see what half of 33 is going to be. So when we divide it by 2, what is it going to equal? Well, we know that 30 divided by 2 is going to equal 15. But we know that 15 plus 15, that's equal to 30. So we need to get to 33. We subtract here, we're missing 3. So how do we get those 3 to go back in? Well, we can give 2 by saying, let's raise this 15 by 16. And the same on the other side. So now we got 16, which means we now have 16 plus 16 equals 32, which now, if we want 33, means we're only missing 1, not negative 1. That should have been there, okay? So we're missing 1. So how do we get 1? Well, we can just say 1, and we can split that up into 2 sides. We do that by splitting it into 0.5, okay? Or you could even say 16 1/2, 16 1/2. So that is going to give us our number now. So we have 16 1/2 is equal to 33 divided by 2. So 16 1/2 or 16 5/10 or 16.5 is going to be equal to 27 divided by 2, which is equal to 27 over 2. So 16.5 is certainly greater than 15. If you run out of room, try to squeeze it the best you can in here. So when you substitute G for 5 1/2, again, just to reiterate here, 5 1/2, where did 5 1/2 come from? Well, if we zoom out here, get a bigger look, 5 1/2 is the number that we substituted in to multiply by 3, because this was 3 times g, and so we took 3 and we plugged in 4 1/2 for g. That wasn't enough, so we needed to increase that, so we increased it by one whole number, okay? So that's where that 5 1/2 comes from. So if you're confused, oh, what are the 5 1/2? I thought it was 16 1/2. No, 5 1/2 comes from the substitution. So make sure that you realize that. So when you substitute g for 5 5/10 or 5 1/2, then, and only then, well, there's other combinations, then the number sentence is true. So we have taken the false statement and we have made it true. Let's go on to number 3. So number 3 says that we need to substitute f with 8. And this is f over 4 is less than 2, okay? Less than 2. You could say that a different way by saying 2 is greater than, 2 is being devoured by Pac-Man, 2 is greater than f over 4, okay? So if we substitute f, let's go through and see what that looks like. So we're just going to take f, and go ahead and make our lines real quick. So we got our division line or a fraction line, however you want to call it. We'll have 4 on the bottom, and then we're going to be substituting f for 8. So f is going to become 8. So this is literally equal to 8 over 4, okay, which is literally equal to 8 divided by 4, right? Following along here, and we'll put in our inequality symbol saying that 2 is greater than that. And then we all know, what is 8 divided by 4? If we were to see 8 in this decomposition bubble, and we divided it out into 4 sections, 1, 2, 3, 4, what could we count by to get each section to contribute to this 8 right here? We could go 2, 4, 6, 8. So 2. If you knew your times tables, it's just the reverse. It'd be a lot easier if you knew your times table. So it actually equals 2. So now we got to look at this. Is 2 greater than 2? The answer is no. 2 is not greater than 2. 2 is the same as 2. If you have 2 here and 2 here, they're the same, okay? It's like when I have my daughters and I'm giving them something because one wants it because the other one has it and they both have the same amount. I'm saying, no, it's the same. It's equal. You guys are equal, okay? So let's write out our sentence. When f is substituted for 8, then the number sentence is false. All right, so what does that mean for making a true number statement? Well, that means that we got to find a different number to substitute out for f. We can't do 8. 8 is going to be equal, okay? This is actually the equals, not greater than, when we have 2 and 2, okay? So if we want something where 2 is greater than f over 4, then f is got to be something less than 8. So if we went 1 less than 8, what would that look like? Well, let's just take a look at what 1 less than 8 is going to look like right now. And we'll use a different color here to differentiate. So instead of 8 over 4, we're going to be trying 7. So we're going to go 7 over 4, okay, which is equal to 7 divided by 4. So now we got to figure out, well, what is 7 divided by 4? It's going to be a little bit messy unless you got some really good mental math, which some of you do. But we can just go over here and solve that by putting it into our division house. So 7, how many times does 4 go into 7? And we know that this is going to be fractions of a number. It's not going to be whole numbers. So we're going to go ahead and put our 0 in there to indicate there's nothing in the tens place right now. We're going to see how many times does 4 go into 7. Well, 4 can't go into 7 2 times because then that would be 8. So it's going to go in once, and that's going to equal 4. 7 take away 4 is going to equal 3. We're going to bring down that 0 because 4 cannot go into 3. So we're going to bring down that 0. 4 goes into 30 how many times? Well, 4 really closely goes into 37 times, which would be 28. Make sure to put your decimal here because, again, it's not wholes anymore. And then 30 take away 28 is going to equal 2. We're going to show that we have another 0 in the hundredths place, and we're going to drop that 0 down. And then we're going to see how many times does 4 go into 20. Well, 4 goes into 25 times. 4 times 5 is 20. And we close that out nice and neat. So we got the answer is 1.75. So 1.75 is indeed less than 2. So when you substitute f for 7, then the number sentence is true. So that's really nice to know that we can figure this stuff out pretty easily using the skills that we've learned before. So we got 2 more that we're practicing on. So let's get these done. They're growing in complexity as we go forward. This number sentence says 14.2 is less than or equal to h minus 10.3. And we're asked to substitute 25.8 for h. So now we're doing a little bit of subtraction using decimals to the 10th places. So let's take a look here at what that looks like when we plug and play. So we have 14.2, which is less than or equal to h minus 10.3. They want us to substitute 25.8 for h. So we'll go ahead and we'll do that right now. 25.8 minus 10.3. So all we got to do now is we have to solve for the problem that they're asking, which is 25.8 minus 10.3. I like to do the vertical algorithm because it helps me to line up my place values. Also allows me to understand whether or not this is going to be a negative or a positive number. I know that 10.3 is being subtracted from 25.8, so we're going to end up with a positive number. So let's take a look. 8 minus 3 is going to be 5. We're going to drop that decimal down. 5 minus 0 is going to be 5, and 2 minus 1 is going to be 15. So again, we'll have 15.5. The number sentence says 15.5 is greater than or equal to 14.2. So this is correct because this is saying 14.2 is less than or equal to. It's not equal to because it's less than. So this symbol, again, if you took the assessment and memorized what you were supposed to, you would know that this symbol means it is either less than on the left or equal to. So if this was ended up being, when we solved this, if it ended up being 14.2, the statement would still be true. So these kind of give us two different things. Oh, it can either be equal, that's why it's half of an equal sign, or it could be less than, okay? So let's see here. Since that statement is true, we're going to have to figure out what's going to make it untrue, but we're going to have to write down in a complete sentence that it was true first. So when H is substituted for 25.8, then the number sentence is true. Perfect. Well, what's going to make it untrue then? Let's take a look. What's going to make it untrue? Well, we know that the left side is going to have to be less than the right side. That's what it's telling us. So our job now is to flip that scenario and make sure that the right side, to make this statement untrue, is to make sure that the right side is less than the left side. Because again, we're trying to make this statement untrue, even though it is true. So we're going to have to plug or substitute a different number in for H. Now, what we did to get to this number is we had to subtract from H, and H was equal to 25.8. So if we want it to be less than the left side, we're going to have to reduce this by at least 1.4, I believe, at the minimum. Because if you were to subtract 1.4 from here, that would equal 14.1, which would be less than 14.2. So we gotta get at least 1.4 taken away. So we can take 1.4 away from 25.8. So if we take 1.4 away from 25.8 minus 1.4 is going to equal 4, drop down the decimal, 4/24. We're still going to be subtracting 10.3 from this number. Nothing changed except the substitution for H, which we changed from 25.8 to 24.4. Okay, so let's take a look if that plays out when we do our substitution in here. So we'll go ahead and we'll say 24.4 minus 10.3. So 4 take away 3 is going to be 1. We'll have 4 and then 1. So we'll get to 14.1, which is less than 14.2. So we got 14.2 on one side and 14.1 on the other. Now this statement is false. This statement is false. 14.2 is greater than 14.1. So when H is substituted for 24.8, 0.4, the number sentence is false. Because it already was true, and our job was to change it to false. So let's scroll down. Take a look at our last example that we'll be doing together. So 5 is 4 is equal to 8 over h. So 4 is equal to 8 over h, and they ask us to substitute 6 in for h. Okay, so 8 over 6 is equal to 8 divided by 6, which is also equal to 6 with the 8 inside the division house. So we know that 6 is going to go into 8 only one time. 6 times 1 is 6. We're going to subtract that. 8 take away 6 is 2. We're going to put the 0 in the tenths place because there is no tenths, and we're going to drop that 0 down. 6 goes into 20. Can't go in 4 times because that is 24. It's actually going to go in 3 times, and it's not going to fully go in. It's going to be 18. 20 take away 18 is going to be 2. And we're pretty much going to get this continuance of 23, 3. So it'll probably just keep on going on and on and on. We will keep it at that. We won't go past the thousandths place. And then we're going to say is 4. So is 4, dropping down the 4, is 4 equal to 1.333? And the answer is no. 4 is not equal to 1.333. 4 is actually greater than 1.33. So we'll write it out over here. When 6 is substituted for h, then the number sentence is not true, it's false. Okay? Period. Don't forget your period. So how do we make it true? Well, to make it true, we have to get something that is going to be equal to 4. So what divided by 8, what can we divide 8 by to get to 4? So instead of substituting out h for 6, what number could we substitute out to get 8 to equal 4 when dividing? I think that's an easy one. We can easily substitute out 2. 2 is going to give us 8 over 2 is equal to 8 divided by 2, which is equal to 4. So if we had 4 originally, and now we have, after substituting h for 2, we have 4, then it looks like what we have is 4 is equal to 4. So let's write out that statement now. When 2 is substituted for h, then the number sentence is true. So what I want you to do is to take all the information that you've learned from practicing with me and taking notes and writing this down in your book. And now you're going to go and do 6, 7, 8, 9, 10 on your own. So you're going to pause this video. Okay, pause it right here and do 6, 7, 8, 9, 10 on your own. When you're finished, you're going to press play. Wait until you're completely finished. Don't give up. Just try your best. Even if you get it wrong, I'm not going to know. It's not going to be graded, because after you're done, you're going to check your own work by watching and pressing play and watching the rest of the video to see what the answers are for 6, 7, 8, 9, and 10. So make sure to watch the rest of the video after you have done the work on your own.